Welcome back to my channel. Okay, we are about to solve the remaining questions that were sent to me. Right, I wouldn't want this video to exceed 30 minutes, so I'll be skipping some questions because it has been discussed in previous video. Like question 14 and 15 has been discussed when we treated the system of particles. So I'm going to question 16. And question 16, I need to write the formula. So the formula for question 16 will actually answer question 15. And then M1, X1, M2, X2, M3, X3 has been given to us. So all I just need to do is write the formula and then substitute the value. All right, so the formula is M1, X1, M2, X2, M3x3 over M1 plus M2 plus M3. So all we just need to do is substitute this value and then simplify our answer. Right, so having substitute all the values in this formula, our final answer will be 0.387 meter. If you have any question, you can drop it at the comments side below. Okay, so we're going to the next question. Right, question 17. Um, Now for the sake of people that will be writing this test, diagram will not be needed, but for those that will need more comprehensive knowledge, should the case, it's more of a theoretical based question. I will be drawing the diagram for better understanding. Right, so having my x axis here, and then I'm having my y axis here, and we're told that is an equilateral triangle. So I'll put my m1 at the origin, which is equal to 1.2 kg. And then since an equilateral triangle, that means all lengths are equal. And so we have a side which is 0.14. So I'm going to be putting my M2 here, which is 2.0 kg. So at this point, my x-axis is 0.14 and my y is 0. So this is x2, y2, this x1, y1. All right, so I have a note that side m3, let's say it's here. M3 is 3 kg. So I'll be joining this point to this point and this point to this point. Remember, sorry, this point to this point, this point to this point. Remember that it's an equilateral triangle, so it means all sides are equal. If the distance from here to here is 0.14, distance from here to here should be 0.14, distance from here to here should be 0.14. All right, let's proceed. Now the center of the mass, it has to just do with the x and the y coordinates. Okay, question 16, I didn't even see the other part. They say, what are the y and the x components of the center of mass of the system? The answer is 0, since it's only one coordinate, one component, which was x component that was given to us. So that of y and z is 0. But for this question, you can see that we have the y and then we'll have the x. Now, mass 3 is at a point, it has to be in respect to y, and it has to be in respect to x. Now, since it's an equilateral triangle, so it means this point will be bisecting this line. So if it's going to be bisecting this line, it's now be the half of 0.14, which will be 0.07 meter. So at this point, M3 at x-axis is 0.07. Now the question is, what is the value of y at this point? We need to calculate it using Pythagoras theory, because right now, if you take a very good look, you're going to see that we have a right angle triangle here. So I'm going to be calculating the height using Pythagoras theory. Right, so using the Pythagoras theory, so I have picked out this right angle triangle. This M3 is at this point, or M1, and then said that this line will be bisected, which will be 0.07. So it now becomes the longest side square equal to 0.07 square plus v square. And then I just did the simplification, take the square of this value and then bring the 0.049 to this point and then simplify it. So it means that the height at this point, the value of y at this point will be 0.12. So this becomes our x3, this becomes our y3. Now what's left is to write the formula and solve. And then we already know the formula for x. This is the formula we use. Y to calculate the center of mass at the y coordinates. All we just need to do is change the point where we have x to y. So I'll be writing the formula now. Right, let's do that of x first. And I would like to do it together. I want us to do it together. So m1 is 1.2. At x1, it's what? 0. Plus m2 is 2.0. And then the point there is 0.14. Plus m3 is 3.0. And the coordinate there is 0.07. So I'll add up the mass, which is 1.2 plus 2.0 plus 3.0. I'm sorry, I will not be doing this together with you for the y coordinate. I just wanted to show you how it is done. So for the y coordinate, you will just see the final answer. And if you still don't understand, you can just leave your question at the comment side. Right, so this is the value for x and this is the value for y. This is the formula. Said change everywhere you see x and puts in the value for y, and the coordinate is here. I've spelled it out. This y1, this y2, and this is y3. So it means that the center of mass, the xcm, comma ycm, and that is 0.079 comma 0.058. And then if you have to look for the value, yeah, it's very simple. So 0.079 should be around this point. It should be around this point where it's bisected, and 0.058 this is 0.12. 0.058 should be around here. So actually this is not drawn to graph. if it was drawn to graph, then we would just use a very good standard scale and can get the point. But the center of mass should be somewhere around here. Right, so let's dive to the next question. Right, this question too is in that same format. Right, so I will just draw the diagram and then explain from the diagram that I've drawn. Right, so the graph will look like this. Actually, not drawn to scale, but it will look like this. And then we're asked to calculate the center of mass. So the same way we solved question 17, that's how we're going to solve question 18. So I'll just go straight away and write the answer. Right, so it will build like this. And then if you're drawing the graph to scale, you can just locate this position in your graph and then it gets the center of mass. So that's going to be all concerning question 18. All right, so to question 19. All right, so we're asked what is a rigid body? Okay, in respect to angular angular motion, a rigid body is a body that can rotate with all its parts being together or looking together and without no change in its shape. Okay, so that will be all that contain the definition of a rigid body. Okay, question 20. Um, with the angular equivalent. Okay, write the angular equivalent of the equation of motion under constant acceleration. So the first thing I'm going to be doing is I will just be showing us the relationship between um, horizontal motion. I think all this are horizontal motion. So I'll be showing us the relationship between horizontal motion and then angular uh, or circular motion. Right, we should know that v, which is velocity, equal this angular speed times the radius, because this has to do with moving in a circular path. So it's all the radius has to be there because radius is related to circle. Okay, but for the question that was asked, what will happen is we're going to be using final velocity, we'll be using angular speed, or we can use angular speed, that's the final angular speed. Then the initial velocity, okay, since we'll be using v and u, so I'll just put this as omega, and then u will be using omega naught. All right, assuming we're using vf and then v high, then we'll be using omega f, omega high. So I'll just be using this and this for our final velocity and initial velocity. All right, so the position is I'm using theta, this distance, this will be the position, and then I'll be using acceleration. This will be our angular acceleration. So the first question was, so the first was v equal u plus 80. So v using omega, u I'm using omega naught, plus acceleration I'll be using alpha, and then I'll be using t. So this that will be all. So the second one, right? So I'm just gonna ahead to write everything. Now there's something I noticed in the question. It was s equals to u t plus 80 square. It's supposed to be half 80 square. So that's by the way. So these are all the equations of motion pertaining to angular motion. So I'm going to go to question 21. Okay, we're asked to take 28 degree in other forms that has to do with angular measurement. Okay, and 0.25 revolution per second and 2.18 revolution per second square. Okay. Um okay, let's write everything that has to do with angular motion. The measure the unit. One revolution equal 360 degree, which is the same thing as 2 pi rad. Okay, so this is everything that we're going to be using to calculate the value. So the first one is 28 degree. So I'll be changing 28 degree to revolution, and then I'll be changing to degree. So if when revolution equal 360 degree, 28 degree will equal x. All we just need to do is cross multiply. X equal 1 revolution times 28 degree over 360 degree. Right, so this will be our answer. Okay, for the next one, it will be 360 degree equal to pi rad. So I'm going to put 28 degree here, and then x, and I'm going to cross multiply. Right, so this will be our answer. Now, by the way, someone will be asking, what is the value of pi here? Don't get it twisted. Pi here is 3.142 or 22/7. When pi is associated with trigonometry like sine, cos, tan, cosine, cosec, cot, the value for pi there is 180. You get. But if we are not seeing those trigonometry identity, pi remains 22/7. All right, so how we will be solving the remaining two the same way I've done this, nothing special, just relating them and then cross multiplying and get our answer. I'm sorry I'm doing this. I just want to save time. Right, so um, it's just the same process as the beginning. So we get the same answer. All right, so this in degree per seconds, and sorry, I think the square. Yeah, and so this is in rad per second square. This the same thing, rad per seconds, degree per second. You can actually use the degree sign. I just felt like writing it. It looks more better writing it. So that will be all concerning question 21. So I'm going to go to question 22. All right, question 22, we'll be doing it together. Okay, so um the spin dryer of a washing machine revolving at 900 rpm means revolution per minute now slows down to 300 revolution per minute while making 50 revolution. Find the angular acceleration. So the first thing I'm going to be doing is I'll be converting revolution per minute to radian per seconds. And after doing that, I will now simplify it into the formula. So I'll be converting one of them to rad per second, and then the other one I will just do what I do. And the same thing with the 50 revolution. I'm going to be converting it to rad to that's to radian. Okay, so the question is, what is 1 revolution per minute? Right, we know that 1 revolution equal to pi rad, and we also know that 1 minute equals 60 seconds. So it means that one revolution per minute will be equal to 2 pi rad over 60 seconds. Right. So we have 900 revolution per minute. So to convert this now, it will be 900 revolution per minute times 2 pi rad over 60 seconds. So this minute will cancel this minute, this revolution will cancel this revolution. So everything here will be 30 pi rad per second. So what is happening here is 60, 0 will cancel 0, 2 here 1, 2 here 3, 3 here 1, 3 to 90 will be 30. So the units remaining to be 30 pi rad, 30 pi then rad per seconds. That's how we got this. So if I want to convert 300 revolution per minute, I'll be multiplying it with 2 pi rad over 60 seconds times minutes revolution. That's 1 minute per revolution. Minutes will be cancelled minutes, revolution will be cancelled revolution, and 0 will cancel 0, 2 here 1, 2 here 3, 3 here 1, 3 to this 10. So everything here will be 10 pi rad per second. I think we still have one. We have 50. Right, so this order we'll be having, we have this, we have this, we have this. So now we need to now assign what is this, what is this, what is this. Okay, so the initial angular, let me see from the equation. Okay, the initial angular speed is 30 pi rad per second. The final angular speed is 10 pi rad per second, and then the angular distance is 100 pi rad. Now the question is, what formula do we use? Now from what question is that? Question 20, we'll be using this formula that says the final angular speed equal to the initial angular speed plus 2 angular acceleration times the angular distance. So we're actually looking for the angular acceleration. So I'll make it subject to the formula and now substitute my value and get my answer. Right, after making angular speed, the angular acceleration, the subject formula, this is what we have in. So I just substituted the value and then the square of each. Mind you, when the square is going in, it goes in for both the magnitude and every unit. So that's what we're having this. And then we're having a negative sign because the final angular speed is greater than the initial angular speed. So 200 in itself 1, 200 in 800 is 4. This pi will cancel one of this pi. This rad will cancel 1 of this rad. So we'll be left with minus 4 rad per second square. So this is the angular acceleration. Right, second to the last question. All right, the formula to use is theta equal s over r, where s is the arc length, where r is the radius, and then we'll just simplify and then convert. Sorry about that. Right, so this is what it will give us, and then we converted rad to degree because the question said we should leave our answer in radian and then in degree. So that will be all concerning question 23. I'm so much interested in question 24. I hope 4 minutes will be enough to explain this. Right, this question 4 we might shoot a lead to above 30 minutes. Okay, the first thing we need to introduce is, since we're given angular acceleration and at the point we're given t equals 0 and then we're given angular velocity as 5 rad per second, then we need to know that acceleration on horizontal motion is the change in velocity over change in time. So it means angular angular acceleration will be the change in angular speed over change in time. So mathematically, what I'm saying is angular acceleration is the change in angular speed over change in time. If I put over 1 and then I cross multiply, it means the W equal alpha the T, and then we're trying to look for angular speed. All right, to take away differentiation, what we do is we integrate. So we are going to integrate both sides, and then if we integrate both sides, what we'll be having, I said integration is an anti-derivation, so they cancel out. So what we'll be left with is omega equal the integral of angular acceleration, let's see. Okay, so from the question we know that angular acceleration is 3t squared minus 4t. So we'll be integrating this in respect to time. Right, this time, this angular acceleration, that's what we just finished writing now. So let's integrate it. All right, so this is what we have in. I said we'll be shooting a little bit 30 minutes because I really want to explain this. All I did was I splitted it. So in integration, all we just need to do is add the power here with 1. The value we get here, we'll divide everything by it. So this is what I'm saying. If I want to integrate 3t, I'm writing 3, follow me, t, this is the power 2 plus 1 over the value here, 2 plus 1, minus, let's do the same thing here, 4t, the power here is 1 plus 1 over 1 plus 1, and we always have a constant c. So it means that this now becomes 3t to the power of 3 over 3 minus 4t squared over 2 plus c. This we cancel this 2 here 1, 2 here 2. So it means that our angular speed equal t to the power of 3 minus 2t to the power of 2 plus c. But we can just have c here. We can actually find the value of c using the information given to us in the question. Let's go back to the question and see. We're told that at t equals 0, the shed has an angular velocity, that's w, equal 5 rad per second. So this is w, this is t. Now let's substitute the value there and see if we can get the constant. All right, can you see w here? So w here, let's just say w omega. That is the angular velocity, is 5 rad per second for every time that t equals 0. So at t equal 0, so anywhere we see t, we just put in 0. So it now becomes 0 to the power of 3 minus 2 times 0 to the power of 2 plus c. So now this now becomes 5 rad per second equal 0 minus 0 plus c. So therefore c equal 5 rad per second. Now we can now substitute the value for c here. We can't have a value like this. This c has to be a number. That's why we went through the stress. So it means that w equal t to the power of 3 minus 2t to the power of 2 plus 5. Now the unit for everything here is rad per second. So this is the expression of angular velocity w as a function of time t. It's as simple as that. So let's do the last one. Let's look for the expression for the angular position. All right, the same way we did that of the angular acceleration to angular speed, that's the same way we're going to do angular speed to angular position. We know that speed is actually changing distance over time. So angular speed will now be changed in angular position over time. The same thing we did, we're going to cross multiply the theta equal omega the t. We want to take away this derivative, so we integrate both sides. It now becomes theta equal to the integral of omega the t. Now what is omega? Omega is what we just finished solving initially. So I'll just plug in the value, equal integral of t to the power of 3 minus 2t squared plus 5 dt. So I will be splitting each and every one of them. And someone will be asking, is it necessary to split it? No, it's not necessary to split it. We can just go straight ahead from here and then just find the integral. I'm just doing this so that I'm going to explain further. So as we've discussed earlier, it will be, this value is 3 plus 1, it's 4. So I'll be having c to the power of 4 over 4 minus 2 plus 1 is 3. So I'll be having 2t squared, 2 to the power of 3 over 3. This 2 is actually the constant, so I just brought it out, plus, now the question is t here? Actually t is here, so let's just do something fun here. So we have an integral of 5. What do you think the value of t here is? T to the power of 0 dt, because anything to the power of 0 is 1. You get it? So there is this invisible t to the power of 0. 0 plus 1 is 1. So this will be over 1. So it will now be 5 c to the power of 1 over 1 dt. So it means when you're integrating a constant in respect to something, it will just be that value and then t, like we've just explained here. Because 5t to the power of 1, sorry, there's no dt again, over what? Over 1. Anything over 1, it's the same thing. Mind you, let's not forget to put our constant c. Let me use c prime to differentiate it. So everything here is the angular position. But we can't just have c. We need a value for that c. So how we go back to the question and get certain information. All right, at t also equals 0, we're told that the reference line on its angular position is equals to 2 rad. So it means that theta here is equals to 2 rad at t equals 0. So the same thing we did for the angular acceleration and angular speed is the same thing we're going to do. So at t equals 0, angular position equals 2 rad. So I'll put in the value 2 rad equals 0 to the power of 4 over 4 minus 2 times 0 to the power of 3 over 3 plus 5 times 0 plus c prime. Everything here is gone. So it means c prime equals 2 rad. So I'll substitute the value here. So it means angular speed in respect to time equal t to the power of 4 over 4 minus 2t to the power of 3 over 3 plus 5t plus 2. So this is the expression for angular position of the shirt in terms of the theta in respect to time. So the reason why we went through all the stress is because we can't have c to be a constant. It has to be a value. If those information were not given in the question, then we leave our answer like this. But provided certain information were left in the question, then we need to utilize it and get this. All right, thank you very much. We'll meet another time by God's grace.